Today we're going to talk about verifying trigonomic identities. We have been talking about simplifying identities. There's a difference between verifying and simplifying. When we verify, we have we're saying that one thing is equal to another. We have to prove it. And when we prove it, the way that we do this is we leave one side perfectly alone. We say we're going to prove that something is equal, for example, in our first problem, to the cosine of x squared. We're going to prove it to you. Remember, when we do this, we do not touch one of the sides. We can pick which side we want, but we don't touch it. And then we work the other side through to show how this is true. This is all about algebra and all about our trig identities. So think of those two things. If you can't find a trig identity, think something about algebra. Look at your strategies. We have 2 pages of strategies and the pink page of identities. So it's somewhere on there. All right, so let's look at the first problem. What can we do? Well, first of all, we can write everything we can write things in terms of cosine and sine. So obviously we start with the more complicated side. Not obviously. We start with the more complicated side. So let's do the left. We're going to take the numerator and write cosine of x and take the secant and write it in terms of cosine times 1 times the cosine of x. Now, let's start with the numerator. We've got 1. What else can we do with the denominator? We have 1 plus the tangent squared of x. How else can we write that? Well, we can write that as a Pythagorean identity. So we could say that is the secant squared of x. All right, what's going to wash out here? The cosines are going to cross out because anything divided by itself is 1. So that becomes 1 over the secant squared of x equals the cosine squared of x. I should use different colors. So then what is 1 over the secant squared? Well, that is, in fact, the cosine squared of x equals the cosine squared of x, and there we have it. Check. We have verified that this identity is true. See that? All right, let's go on to number 2. Well, obviously the left side is more complicated, so we will work with that side. We're not going to touch the right side. Now, what are we going to do first? We know that when we use this is a cofunction identity. So we're going to start with that. We're going to say 1 plus, what is this? This is going to, cofunction identity says this is simply the cotangent squared of x. That's what the cofunction identity says. So we leave that as it is over. Now, what does our odd and even function say about the sine of negative x? So we look at the sine. Let's look at the sine function. When we have the sine function, what does the sine of negative x equal? If I have the negative x, the sine of a negative x, what is it equal to? It is equal to the negative, it's equal to this exact thing. Let's start with this. If this value right here were negative pi over 4, what would be the way the sine function works? It would be exactly equal to the negative of, the negative of the sine of the same value. Then you'd have to put a negative on the positive sine value. So the sine of the negative value of pi over 4 would be equal to the negative sine of x. Okay, so we leave the right hand alone. Negative cosecant cubed of x. And I don't know how that's, we'll just leave that alone. All right, what do we do next? What can we do with 1 plus the cotangent squared? Well, that looks like a Pythagorean identity to me. So we look at our Pythagorean identities and we say, yes, it is. That is the cosecant squared of x over the negative sine of x. And that is equal to, leave the right hand alone, negative cosecant cubed of x. What can I do with the cosecant squared of x? Well, I can write that as well, first of all, what can I do with the sign in the denominator? Let's write that as a fraction, as 1 over the cosecant. So I can say that the cosecant squared of x over negative 1 over, what's the reciprocal of the sign is 1 over the cosecant of x equals negative cosecant cubed of x. Now what can I do? How do I do this division? Well, I multiply the numerator by the reciprocal of the denominator, which is the cosecant of x. What can I do here then? Multiply cosecant squared times cosecant of x, which gives me, and then I still have, this is still negative, so my end result is the negative cosecant cubed of x is equal to the negative cosecant cubed of x. Okay, so there we have it, verified function. Alrighty, let's go to number 3. Looks a little more simple. Obviously, the right side is more simple, so let's work with the left. And we have the cosine of x, which will keep the same, cosine of x. What is the secant? Well, what's the inverse of the secant? We will rewrite the secant as a cosine times 1 over the cosine equals 1. This is very simple. The cosine simply cross out, and I get 1 equals 1. Wow, it's very nice when it's that easy. It's not often that easy. Okay, tangent. Well, let's do number 4. Well, it seems to me that the best thing to do would be to write everything in terms of sine and cosine. So the tangent would be the sine of x over the cosine of x times 1 over the sine of x times the cosine of x equals 1. Again, always not touching the simpler side. So what can we do from here? Well, we can cross out the cosines. They cross out. We can cross out the sines. They cross out. And what am I left with? 1 equals 1 and done. Okay, got easier. All right, 2 more to go. Okay, looking at number 5. Again, it seems that the first strategy that would be appropriate would be to change everything to sine and cosine. So let's start there. The sine of x plus the cosine of x times the cosine of x over the sine of x is equal to the cosecant of x. So now I have the sine of x plus the cosine squared of x over the sine of x equals the cosecant of x. Now it looks like I'm going to be working with some denominators, so I'm going to give my first term a denominator. Looks like I need common denominators. So what would be my common denominator? Well, it would be this, I need a sine of x. So let's make this a sine of x. To give this a sine of x, I need to multiply the numerator by sine of x. So my common denominator is the sine of x. And so this would be the sine squared of x plus the just cosine squared of x equals, do not touch the right hand side. Okay, what can I do? Pythagorean identities, sine squared plus cosine squared is 1 over the sine of x. Am I still on the board? Yes. Equals the cosecant of x, and I'm almost there. What is 1 over the sine of x? It's the cosecant of x equals the cosecant of x, and check. Verified identity. All right, one more. Now, I can see Pythagorean identities right away, so I'm going to make substitutions right away. This is the more complex side. Cosine squared plus sine squared is 1. 1 plus the tangent squared is the secant squared of x. Make sure that I've got that right. Yes. Equals the cosine squared of x. Do not touch. What is 1 over the secant squared? Well, that is the cosine squared. Equals the cosine squared. And I'm done. I have verified the identity. All right, we've seen 6 examples of how we can verify trigonomic identities. So we will be practicing that more in class. And of course, they get a little more complex. There we go.